So, welcome to this lecture. As you recall, we have looked at the concept of limit and continuity in the previous lectures, and now time has come to look at some of the applications of these concepts in our topics of economics, commerce and management. So, let us begin with an example. So, consider a manufacturer of a car who uses some bolts in the manufacturing unit, and the data given is that 20,000 cars are produced each year, right. These many cars are produced each year by that manufacturer, and each car uses 1050 bolts for the manufacture of each car. So, if you want to interpret this relation between the two, so these many cars are produced and each car uses these many bolts. So, what is the total number of bolts that is being used? So, we can define the relation between y, the number of cars produced, and x, the number of bolts used, as follows. The total number of bolts that are used is x is equal to 1000 into y, where y is the number of cars produced. Or we can interpret y in terms of x. So, y is equal to x divided by 1050. So, here y is the number of cars being produced and x is the total number of bolts that are used to produce those many cars. So, each car using this much. So, of course, this is a linear relation, but the only drawback in this data is the number of cars or the number of bolts are going to be numbers. They are integers, right. They are actually positive integers, so they are natural numbers. So, we cannot treat y as a function of x as a function on the real line and talk about continuity of this function. Of course, one can talk about continuity, but that really does not make sense in this scenario. So, so this goes to the what is called the modeling of the problem. For modeling of the this problem, number of cars being produced, number of cars being produced and number of bolts being used for each, one can treat them. So, that is the assumption one makes in modeling, that for the variables which are at present discrete, they are taking values which are numbers, we make them continuous and say this relation is followed for all practical purposes for mathematical analysis. So, that is one, and then one can ask continuity, and then we know that every linear function is continuous. So, then it will be y as a function of x will be continuous, right. So, in the modeling relation, we can treat it as a function from r plus to r plus y as a function of x, and then it is a continuous function. Okay. This is a very simple illustration saying how from discrete data one goes to a continuous data. Right. Let us look at our next example. Our next example is model of salary with bonus model that is followed in many forms. So, the model is as follows, namely, consider the earning of a sales executive of a firm, right, and some executive who is in the sales department of a firm. So, his earnings are as follows. He gets a fixed pay of 8,000 per month. So, that is a fixed pay being on the rolls of that firm, and a commission of 10% of the sales. So, whatever he is able to sell in a month, he gets 10% of that added to his earnings. Right. So, 8,000 plus 10% of the sales and plus an additional bonus of 500 rupees if he does sale more than or equal to 2 lakh rupees in a month. So, there is a incentive bonus given to the executive that if he sells more than goods more than worth 2 lakh rupees, then he will get a 500 rupees of additional bonus for his take home earnings. So, 8,000 plus 10% of the sales plus 500 in case he makes a sale of at least 2 lakh in that year. So, let us see what is happening. Then his total take home will be, if his sale is less than 2 lakh, then 8,000 plus 10% of the sales, let us call sales as S. So, his take home depends on the sales he makes. So, 8,000 plus 10% of S, that is his take home. If it is less than, if it is greater than or equal to, as soon as he crosses his sales cross 2 lakh, he gets 500 extra. So, that is, this is a expression for his take home pay. You can call it as PS is his take home pay is dependent on the sales, right. So, it is 8,000 plus 10% of S if the sales is below 2 lakh, and if it is 2 lakh and above, then 500 more is added to it. So, let us draw a picture of this, a graph of this. In both cases, it is a linear function, right. PS, this is a linear function, Ax plus b, and this also is a linear function, right. So, what is happening is, this is the point where the things change, sales. So, on the x axis we have put sales, and on the y axis is take home earnings. So, if the sales is below 2 lakh, if there is no sales at all, he anyway gets 8,000 rupees, right. And sales up to 2 lakh, there is a 10% increase. So, there is a 10% increase in sales. So, it keeps on increasing his take home till he reaches 2 lakh. So, at that time his sales will be 28,000, right, 10% increase, 8,000 plus 10%. So, of 2 lakh, that will be 28,000, right. Now, as soon as he reaches this, he gets a jump in his earnings. There is a jump in his earnings, right, 500 more is added. So, 28,000 plus 500, and then again whatever more sales he makes, it will keep on increasing, right. So, this is the take home graph versus the sales in that scenario, where 8,000 is the salary per month, is the take home per month, that is a fixed thing, fixed earnings per month, and then there is a varying thing which is 10% of the sales. So, there is sales 10% of the sales, and as soon as the sales reach 2 lakh, he gets a jump of 500 more, and again proportionately same. So, this linear thing is parallel to this linear thing, and if you remember that formula for the slope, right, slope is 1 over 10. So, it is an increasing function. So, this will be parallel to this, only there is a jump here. So, in this graph, there is a discontinuity at the point 2 lakh in the sales. At that point, there is a jump discontinuity for the function, right. Okay. So, that is as much as mathematics. What is the interpretation of this from the economics point of view? So, let us take the example, there are 3 employees in the company A, B and C, and total sales of the month except on the last day. The 1 month is left before the month is over. So, 1 day before the end of the month, this is their data of their sales that they have done. A has made a sale of 2,60,000, B has made a sale of 1,80,000, and C has only made a sale of 60,000. So, these are the 3 executives, and that is the data of their sales on the last but 1 day of the month. The question is, what do you think all these 3 will be doing on the last day? On the last day of their sales, on the last day of their working, what do you think these 3 will be doing? Well, A has already crossed the target of 2 lakh, and he already made 2,60,000, and if he does more sale on the last day, he will get only 10% of that more, right. He has already achieved the bonus of getting 500 also. So, most likely he will just relax on the last day, because he is not going to add much to his take home salary. So, he will probably relax. The reason is he already achieved the target of 2 lakh and nothing much to be achieved. Whereas, if you look at B, he is nearing the target. He is 1,80,000, he is just 20,000 short of 2 lakh. So, more likely that on the last day he will make a last bit of effort to make a sale of 20,000 at least more, so that he gets 500 rupees bonus also. So, hopefully, B will be out in his territory trying to make the sales of at least 20,000. Whereas, what happens to the sales executive C? He has made only sales of 60,000 in that month, and even if he is able to make some more sales on the last day, he will get 10% of that, and hopefully, well, in a day, over the whole month he will be able to sell only 60,000, and in a day he may not be able to make 1,40,000, what is the gap to attain the bonus. So, more likely he will also take the life a bit more leisurely on the last day, and he will also relax, because nothing much is to be gained by toiling and right. So, A and C both will not be working most likely on the last day, right. Only B may be working on the last day. So, this is what is happening to this model of bonus. Most probably A and C will not work for different reasons, and only B may be working, right. So, this is happening because the function has a discontinuity at the point 2 lakh, so when the sales is 2 lakh. So, it is highly suggested to the firm that tweak your bonus formula somehow, so that this kind of scenario is avoided and everybody works. What they do, it is their choice. This is not desirable to have a discontinuity in the take home and the sales. The company has to rethink their bonus model, right. So, that is how mathematics helps to make suggestions for economic changes, right. So, let us look at another model. Let us look at in a social security setup, the government decides to give a non-employment allowance of 700 rupees per month to all unemployed adults. So, the government says that is a populist government, which says that okay, everybody who is not employed will get 700 rupees per month as a unemployment allowance, right. So, let us see what is happening in this scenario. However, government says if that is the case, then nobody will be working, right. Says however, the allowance is stopped if the person starts earning, right. Either you just feel happy in your life and you set 700 rupees, right, or you start working and then the allowance will stop, right. So, what is happening in this case, right. So, let us suppose an individual can earn 20 rupees per hour, right. We are just making an assumption, say that an individual who can earn with his skills 20 rupees per hour, then his earning will be given by the relation between his earnings and so the relation between his earnings and working per hour. So, E x is the earnings that he can get 700 if x is equal to 0, that means he is not working at all, right. If he works for x hours, x is bigger than 0, then he gets 20x, right, then he gets 20x. So, let us plot this relation. It is a linear relation. At 0 the value is 700, for x bigger than a value is 20x. So, this is a linear function for x bigger than 0 with slope as 20. So, when we plot, this is what you get, right. So, this is when it is 0, okay. This is the earnings 700, right. So, we have just plotted this part of the thing just to indicate what is this 20x. So, at this point actually it starts here, right, because if he is not working at all, he will be getting 700 anyway, right. If he is not working at all, he will be getting 700. So, if he starts working x hours, right, then to get 700 rupees, right, he has to work for 30. So, his earnings, so if this is the earnings for that person who is working, right, if he works for 5 hours, 20 rupees per hour, right, then he will get only 30. So, to earn 700 rupees, which is a non-employment allowance given to that person, he has to work for 35 hours. Why he should work at all? Probably he will just relax. 35 hours he has to put in the work, right? That is quite a bit of it to get 700 rupees, you have 20 rupees rate. So, most likely he will not work at all. So, this model of the government needs thus to earn 700, he has to work for 35 hours, which is not a very good scenario as far as the government is concerned. So, a modification is suggested. The government takes 50% of his earnings and the person is allowed to keep 50% of the earnings in addition to the allowance of 700 till he is able to pay back 700. So, this is a suggested model. As an employment allowance, he is going to get 700 rupees. Now, he starts working. So, if he works for x hours, so 20x he will get, right. The government will take, so 700 plus 50% of 20x, right, that he can keep. So, his earning is 700 plus 20x divided by 2, right, that is earning till his payback is 700 rupees, right. So, till his earnings become as much as he is able to pay back, that is 700 rupees, and then he can keep all his earnings, right. So, let us plot this model again. Suppose he earns 20 rupees per hour, again same model, right. So, then what will happen? To pay back 700 rupees, right, how many hours he has to work? He has to work for 70 hours, right, because only 50% he is allowed to keep, 50% the government has to get back. So, that means we want to find x such that if 20 rupees per hour he is able to earn and the 50% of that should be equal to 700. So, that is the equation that we get, right. So, that means x is equal to 70. So, that means if he is able to work 70 hours a day, right, then he would be paying back the government, till then he will be reached the target of paying back the government 700 rupees, that is unemployment allowance. After that, if he is able to work more, then he is allowed to keep everything. So, this is the model suggested, tweaked model of earnings and the social security system. 700 rupees he gets anyway, whether x is 0 or whether x is the number of hours, and he gets 50% of 20x. So, that much he will get if he is working less than 70. If he crosses his working hours cross 70, then he gets 20x. That means, the government is sort of encouraging the person to work more than 70 hours a week, so that he can take home everything that he is working. So, in that case, what will be the model? So, here is the earlier it was this line, right, as the earning and so on. Now, what happens if he does not work, he is getting 700 anyway, right. If he starts working, then his take home keeps on increasing till he is able to work at 70 hours per week. So, at 70 hours when he is able to work, his earnings become 1400, and after that his increase becomes much better, because he does not have to give back 50%, is equal to 20x. So, it is the same old graph that starts here. So, in this model, the government is giving an incentive for him to work and reach the target of working 70 hours. So, this is the way one can use continuity to ensure that the people in a social security model, right. So, there is continuity in the graph. Let us look at, so we have seen some applications of continuity, we will see some more in the lectures to come. Continuous functions have some very special properties which I would like to discuss so that we are able to use them, why continuity is important. The first property is called the intermediate value property. It says if f is a function from an interval a b to r and it is continuous function, if alpha and beta are such that f of x1 is alpha and f of x2 is beta, then for every r between alpha and beta there is a c such that, right, f of c is equal to r. So, understand this as intermediate value property, that if a and b are f is a function on an interval a b and the value alpha is taken at some point x1 and the value beta is taken at some point x2, then every value r in between alpha and beta is also taken by the function at some point. So, let me draw a graph of this function and try to explain it pictorially what we are saying. So, this is x, this is y, right. So, here is a value alpha and here is a value beta. This value alpha is taken at some point say x1 and beta is taken at some point x2. That means, this point is on the graph and so x1 is beta. So, let us say x1 is alpha. So, this point is on the graph. So, f of x1 is equal to beta, f of x2 is equal to alpha. So, these two values are taken by the function, and the theorem says that if I take any point in between, let us call this point as say r, here r is any point in between, then there is a point c such that f of c is equal to r. That means, this is the point. That means, this if this point is on the graph, this point is on the graph and the function is continuous, then graph must pass through this point, right. So, that means, the graph should look like probably this. Another way of saying the same thing would be the following. Let us say this is the graph of the function. Okay. So, another way of understanding this intermediate value property is the following, namely, let us take the same picture. So, this is x, this is y, and this is x1, and this is x2, this is the value alpha. So, this is the point, and at x1 the value is beta, this is alpha, this is the point, right. Okay. So, these 2 points on the graph. So, this, let us say graph is equal to this. This is the graph of the function f of x. So, f of x1 is equal to alpha and f of x2 is equal to beta. We want to say that if I take any value r in between alpha and beta, then this value is taken by the function at some point. Geometrically, that means what? That means, if I draw this line, then it must intersect the graph at some point, because then this will be the point C where the value r will be taken. Actually, in the picture I have drawn, there are 2 points, this point and this point where this value is taken. So, theorem says that there will be at least one point where the value will be equal to r. So, this is what is called the intermediate value property, because if this value is not, so what does that mean? If this value is not taken, let us also look at the negation of this statement. If this value is not taken, what does that mean? So, let us look at this graph again. This is x1 and this is x2. So, this is the point beta and this is the point alpha. So, this is the value, right. Now, the graph, the function has to start, right, at x1 it has to start here and go here, and let us say there is a point where this value is not taken. So, this value r, suppose it is not taken. That means what? That means the graph cannot intersect the line, this red line. So, it has to start here and go here. So, it goes somewhere. Now, it cannot cross. So, that means what? It can come closer and closer, but it cannot cross. So, it has a jump, right. So, maybe it will start somewhere else, right. So, it will start somewhere, say for example, this point and then go here. So, there will be a jump in the graph of the function. So, that point C, right, there will be some point in between where it will have to jump over that line. So, if the function starts and it doesn't have to cross, then it has to jump over and then goes here. So, there will be a discontinuity in the graph of the function. So, for a continuous function it must, and this also means that, see, if this is the case, if this is a scenario, then what is the range of the function? So, the range of the function will be this part and this part, where the domain is this, the range is two parts. That means, intermediate value property ensures that the images of intervals are intervals, or this is the mathematical way of saying that the graph of a continuous function cannot have breaks, right. So, this is the mathematical version of the intuitive idea. When we say there is a function is continuous, the graph is a continuous curve. It means if you want to plot that, if you start plotting, you start at one point, then you have to reach the other point without lifting your pen. So, there should not be any break in the graph of the function. That is, mathematically it is because of the intermediate value property. So, we will continue this study of some more properties of continuous functions and their applications in our next lecture. Thank you.